about wind turbines, you think vast, wide, open fields with huge towers up to 325 feet high with blades that can go out as long as 150 feet. But that's not the way to harness the wind's energy. A new invention has shrunk the size of a wind turbine down to a teeny tiny 1.8 millimeters. You could fit a few of these on a carpenter ant or a grain of rice. It could be used as a power source in all kinds of electronics. One idea is it could be a backup battery on smartphones, which seem to lose juice so quickly. Joining me from Fort Worth, Texas, is the inventor of these tiny windmills, J.C. Chow. J.C., it seems so simple, right? We harness energy through moving wind, but we never thought about it for little things. So could we get to a point where I could be blowing into my phone like that to recharge the battery?
Yeah. First of all, it's my honor to be here. Can I call you Ali?
Yeah, absolutely you can.
I feel like
you invented
I know
a tiny windmill. You can call me anything you want.
No. I watch you all the time on television, so I feel like I know you personally. This idea actually comes from a few years ago when I and my student tried to make a windmill on integrated circuit, because we think that there's a lot of airflow in the surrounding ambulance airflow, big winds when you are driving, when you are walking. Why can't we harvest those energy and use them to charge cell phone or any electronics? So that's where the idea comes from. The idea seems simple, but it's actually take us a while to get it implemented.
Okay, so tell me what the limitations are and what the possibilities are of these tiny windmills. How did you, and by the way, how did you arrive at the size? I mean, are these scalable?
Yes. First of all, these are research results, so the dimensions are not optimized. So we don't think this is the final product platform. Second of all, the limitation is that because they are small, so they can only harvest a very small amount of power. But today, almost every day, the requirement for power in the integrated circuits keep going down. So I believe that in the near future, we may be able to use the tiny power to drive an integrated circuit or electronics product. And second of all, because all these devices, they are so small, so in a very small, limited space, we can actually fit quite a lot of them to harvest the energy. Well, for example, like a half size of the iPhone can fit 1,000 of this windmill. Any small number times 1,000 may become a significant number. So we believe that in the future, either we use this device to power up very small devices, or we use an array of them to generate enough power to power the device directly or charge a battery.
Now, you are a professor of electrical engineering at the University of Texas, Arlington. You're also an associate professor of internal medicine, which makes me wonder, is there a medical application to this?
Actually, my research group focus on medical application. We build implants such as brain, spinal, esophagus, stomach, bladder implants. And the power is always an issue. Replace the battery in those implants take surgery. So it's not fun for the patient, and not to mention that this is very expensive. So what we first thought about was, can we invent a device that can continuously using body motion, using our blood flow, using our heartbeat to power up those devices. So part of the reason we are working on this is for the future use of in medical devices.
Let's talk about commercialization. It seems obvious to me that if you succeed at this, that it's something that will be commercialized. Are you already in sort of advanced talks with major companies?
Currently, there are quite a lot of companies contact us, from big commercial company to small star private company. So as a university, we are taking this in a slow way. Try to identify what would be the right path for us to focus, because we have limited resource, and also university's job is to mentor the young engineer, young scientists. We are trying to invent and try to solve the obstacle for future commercialization. So for us, we are still in the process to identify what kind of company or industry we should be working with.
Amazing. I hope it's ubiquitous. I hope it's all over the place. What a great idea, and I hope you succeed with it. J.C. Chow, Professor of Electrical Engineering at the University of Texas, Arlington. All right, coming up, tense times.